Hello everyone and welcome back. Our next talk today is around the topic of turning data into tangible assets in the maritime industry, presented by Juha Asanti, Vice President of Maritime at Cadmatic. So without further ado, over to you.
Okay, thank you. Thank you for the introduction. So hi and good afternoon. So as introduced, so my name is Juha Asanti and I currently work as a Vice President for the marine industry for Cadmatic. Technology moves in strange ways. So when you hear the phrase digital assets in 2024, so your first thought might be related to cryptos and these kind of, let's say, digital currencies. But a digital asset can take, let's say, many forms. In shipbuilding, the sector is beginning to realize how the vast amounts of data that each project holds and creates. So how they are kind of assets on their own. And this is driving the development of the tools to manage and organize and leverage this data to power the vessels of the future. So in this presentation, so I will go through a few key elements explaining how and why data should be seen as a digital asset in shipbuilding. Also, I will walk you through how shipyard operations consist of massive amount of different kinds of data coming from the past and collected during each new project, each phase in the project, and how that is utilized by different stakeholders. Also, I will briefly explain how the data flow supports design and construction processes via digital manufacturing, addressing change management for stakeholders, management of related documents, and integration with emerging technologies such as AI, additive manufacturing, smart vessels, and smart shipyards. And then I will conclude by explaining how digitalization, let's say through Cadmatic's CAE, CAD, CAM, and PLM systems empowers the maritime industry by facilitating the digital journey, streamlining work processes, and unlocking the potential of digital models for the utilization of digital twins. So let's say at Cadmatic, so we've been talking about this kind of a digital revolution via data-driven shipbuilding for quite some time already, for actually a few years already. And what we mean by this is how to kind of maximize the automation of data handling from early design throughout all the design phases up to construction, production, and operations, and how the utilization of model data for scheduling, planning, production, maintenance, and operations management can be, let's say, utilized in the best possible way. Also, how the production planning based on real-time situation instead of historic situation is let's say a modern way to do planning. And then also the kind of embedded use of technologies such as augmented reality, virtual reality, mixed reality, and the possibility to integrate this with RFID tracking, IoT, and metaverse for the next level digital transformation in shipbuilding. As a kind of an end result, so we have a digital mock-up or digital twin of the project consisting of all the data from numerous data sources and collected throughout the project duration, kind of incrementally increasing as the project matures. And then having this digital twin accessible by numerous project stakeholders. And let's move on by going through. So what kind of a data are we talking about? So as we know, so shipbuilding and ship design and shipbuilding are complex processes requiring collaboration between hundreds, if not thousands of people, thousands of drawings and millions of euros or dollars. And managing this information within these projects is essential to their success, both in terms of commercial performance, delivering vessels to specification and budget and as scheduled, delivering the performance and safety the industry needs. And let's say tools for automotive industry or aviation, for example, operate more on product basis. So let's say in the example of a car, so there's first extensive research and design and prototyping, and then once the design is complete, so you can produce millions of the same cars with the same design. And aircraft design obviously follows a kind of a similar pattern. But let's say when it comes to shipbuilding, so every vessel is a one-off, even between the sister vessels, so designed to fit for a specific commercial need or requirement. And let's say here we have an actual case study or case data from one typical commercial vessel project. So just to give you a rough idea of what kind of data, types of data and amount of data we are talking about. So there's around 5 million parts, each highly interconnected, let's say with topology and classification. There are different disciplines such as hull structure, piping, outfitting, electrical, HVAC, interior, and so on and so on. Varying number of designers, all the way from, let's say, 100 to 1,000 in different locations, constantly doing changes to the design, to the 3D model, to the data, which is interconnected. Approximately 20,000 documents of different kind, and several subcontractors working on the project at different building sites. So all in all, a very, very complex project from data management point of view, with different kind of project participant with different needs at various times and stages of the project. Then let's say as the data is incrementally created during the project, so what are the kind of benefits of this creating a digital twin and data flow, or let's say consistent data flow throughout the life cycle? So regarding, let's say, design and engineering, so designers have access to latest design data, sketches and revisions while modeling, and then the design department can check production status and progress as and if needed. Planning and work preparation, so they are kind of working on the same integrated model, integrated data, and progress is tracked according to actual planning, not based on historic data. Prefabrication concerning that, so clear benefit is that these people have access to the latest revisions in the model, and they can keep others informed about the production status, which thereby enables just-in-time pre-production. Then we have fabrication and assembly. So production has access to latest data and can look up information without need to go back to engineering. And then in the end, so let's say after delivery, so we can utilize, let's say, online data from the vessel once it is sailing, and allow this kind of remote viewing with AR, VR type of technology for retrofit proposals and inspection, and access to all data which is generated during production when in operation. And with this kind of predictive maintenance, so maintenance cost and cycles can be reduced. Then a few words about, let's say, what we call visual shell for information management. So designers and engineers, project managers, so they handle these kind of unique, complex designs within a 3D CAD design and its associated documents. And matching up these documents with each other with rapidly evolving 3D models is not an easy task, obviously. So thanks to number of variables involved, so there can often be significant deviations between, let's say, designs as engineered as compared to as visualized, as designed, or as built. If the projects are not, let's say, carefully managed. And gaining kind of control of this variation is one of the major challenges regarding data and process management. So how to tackle this challenge, or how to meet this challenge? So it's not just about putting all the data in one place, but it's about to building meaningful connections between the data and the documents and all the information, all the metadata they contain. So let's say if the sheer amount of information in each project is a kind of a data lake, so it would and will require shipbuilding specific knowledge to dig into and catch the most useful insights. So this is where shipbuilding specific expertise is in the key role. Shipbuilding CAD is very specific, so individual parts are not just stored together, but instead as topologically connected to each other, and making these kind of meaningful, let's say, connections and organizing them in a way engineers and managers can use. So that's in the focus of let's say Cadmatic's wave application, for instance. That's to use existing proven technology, and then on top of that, so build this kind of shipbuilding specific expertise, and that way make the best use of this technology and kind of turn that data into a real digital asset. And to continue, so let's say shipbuilding projects are often referred to as R&D type of projects or process due to the nature of being very complex and constantly developing with technological changes. So for successful completion, this then requires specialized apps to support data creation and management. Requirement and specification management, and also project management, and then let's say overall process management with the necessary workflows. And let's say, needless to say, that every vessel is a unique project with its own sets of challenges, requiring a focused tool for effective data management. Yes. Yes, and treating data as a digital asset. So we can have a short look into digital manufacturing as well, and to see how this asset can be utilized in let's say digital shipyard environment. There are three main components to facilitate digital manufacturing in shipbuilding. Out of which the first one is the kind of design and engineering data. So that is coming from the CAD and CAM applications. And for example, so Cadmatic's applications have plenty of interfaces to extract this kind of production data and use it directly and automatically in NC machines. And these are, for example, direct connections to nesting applications, interfaces for shell plate bending machines, welding, manufacturing, robotics, and much more. And this data is often enriched with EBOM, so engineering bill of materials, manufacturing bill of material, work breakdown structure, production method, and so forth. And yet to add this kind of production simulation data, and we have quite good and comprehensive coverage of design data coming from CAD and CAM applications for manufacturing purposes. The second part being integrated scheduling and planning. So this task is typically executed with data management software. And it allows planning on the level of parts and assemblies, thereby making a virtual model align with the virtual process of production. It can align, for instance, with SAP data management and serve as a visualization for bill of process. Export management allows the structure of bill of materials based on needed processes. So, for instance, design and manufacturing services and so forth, without changing the content of the data. And then the third component includes data about machinery and logistics used by the yard. So it can be a full model or only kind of detailed information about each machine in the process. And then having this kind of direct interface for IoT machinery allows for monitoring of work status, scheduling based on correct data from planning and design, setting KPIs, monitoring bottlenecks in the production. And this kind of additional tasks include quality compliance and maintenance of machine scheduling. The resulting benefits are full insights into machinery status and process and data alignment. So let's say when it comes to digitalization in shipbuilding, so we pose some challenges and opportunities. As a first one here, so there's a high degree of project complexity. So the vessels are becoming more and more complex, which then of course has an impact to the design engineering phase, to the building phase throughout the whole process. So how this is changing the landscape. Deep kind of specialization is required for each discipline at the yard. Then this kind of there's a lot of complexity, more complexity nowadays going forward. So how to have this kind of continuous flow of data between different disciplines throughout whole project stages, and also between different stakeholders in this networks of companies and subcontractors. Fragmented and disconnected IT landscape is what we are seeing very much still today. So meaning shipyards have a lot of, let's say, applications which quite rarely are interconnected and integrated. So means that there's a kind of a separate islands of data still existing also in the modern shipyards. So and then the management of distributed collaboration. So as explained, so there's a number of suppliers, a number of let's say project stakeholders, networks, and so forth. So how to manage this whole distributed collaboration from data management point of view. Green technology and sustainability, as we all know, so becoming more and more important, and that poses new, let's say, requirements to the shipyards, to the, let's say, projects, to applications and data management as well. And then still a lot to do, let's say, on this field generally. So how to extend this data use for the whole life cycle, and also then including operational data coming from the vessels once they are sailing, and kind of trace that back to design engineering to be utilized then in let's say future projects. And then the shipbuilding 5.0 or industry 5.0 used in shipbuilding, digital transformation. So data to human or machine to human interaction combined with sustainable goals and shipbuilding expertise. So kind of how to manage this whole landscape. And the kind of benefits of dedicated PLM, so they go beyond project managing the design and construction of the vessel. And currently, so beyond the sea trials and after first year of vessels operation, so a yard bears little responsibility for the vessel's performance. So after this first year, for the next 2 or 3 decades of a vessel's lifetime, owners and operators need to reconstruct the vessel's design data to handle services, like for instance hull cleaning and retrofits and other maintenance related activities. Building a shipping specific PLM system enables an alternative by creating a digital twin that owners and operators can then use throughout the lifetime of the ship for repairs, service, and improvements. PLM built around shipbuilding needs not only enables, let's say, more reliable but also efficient and manageable building process, and also kind of creates digital assets to be that kind of benefit the vessel, crew, owners, and operators for decades to come. Shipyards are hubs that house a range of dedicated expertise and skills, engineering, IT, project management, and much more. And PLM systems designed for shipbuilding will be the foundation for making the most of these skills as shipyard, let's say, delivers the fleets of the future. So with that, I thank you and leave room for eventual questions.
Great. Thank you very much for another great presentation. A lot of very topical things in there, and a lot of tools that people are thinking about. So interesting to get your perspective and guidance on how we can make that journey together. I've got probably time for just one question, and that is around what makes shipbuilding different to other industries when we're talking about digitalization. Talking especially about the vast amounts of data that are involved in a ship design model as compared to an automotive model, for example.
Yeah, well, it's totally different industry from that point of view. So if we compare to car manufacturing industry, for instance, so typically you design and engineer and you make the prototypes, and then once that is complete, so you start the production and off you go, so to say. So there won't be further changes in this coming to this model, and you produce massive amounts of the same, let's say, product, more or less. But when it comes to shipbuilding, so each vessel, whether it's even sister vessels, so they are unique. They are very one of its kind. and projects tend to take years to complete. And throughout these years of duration, there's a lot of changes coming from here and there. So how to manage all this? So from that point of view, much more complex industry, or let's say product, is a ship as compared to car. And this is also where the shipbuilding expertise plays a critical role.
Brilliant. Thank you very much. Thanks for another great session, and hope everyone will join us for the next one. Thanks again.
Thank you. My pleasure. Okay, bye.